Hey guys, another Leetcode question today. So we'll be doing open the lock. So I'm excited for this one. Let's see how it goes. All right, so let's start the open the lock question. So I always go to my iPad and start whiteboarding out the question, really understanding the description. So I'm going to do that now. And we are a success. Whew. Wow. Very nice. All right, so I feel good about that. Just shows that hard work does pay off. If you set your mind saying that I have to finish this, because there were times while I was doing this question that I wanted to look at the solution really bad because I was just in total confusion of what to do, but really helps me whiteboard out the problem on my iPad, or if you have a whiteboard, piece of paper, whatever. Keep whiteboarding it out, get to an initial kind of starting point, start coding it up, and it typically works out. If not, keep trying over and over again. All right, so let's do a recap of the solution that I created. Hopefully it'll help you out. So at the beginning here, I do some validation as always to check the inputs. So if dead ends is null, or if the length is less than 1, then we return -1 right away. So as you can see from the description, we need to return -1 if we cannot reach the target. So these cases would make it impossible to reach the target, so we return -1 there. All right, and then I had the idea to create a set because all these dead ends need to be referenced somehow based on the way that we're doing the implementation. So I dump all of the dead ends into a hash set, a string hash set. So let's say all the dead ends are these ones here. I put those all in the set so I can reference and check them in O1 time to see if we're hitting a dead end or not. Great. And then there's one little edge case here. If one of the dead ends is the first starting point, then we need to return -1. So that was one of the failures when I submitted it here. The wrong answer that I got here was because they gave an input of a dead end that was at the starting point. So a little tricky, but just added that in there, and that was able to fix that test case. Cool. So added all those in there. That looks good. And then I created a queue based on the deck interface. array deck implementation. And then I declared a count variable. So this is going to be part of our algorithm. Let me back up a little bit. We're going to be using the breadth first search algorithm. And on my iPad, let me show you real quick, just kind of the summary of what the algorithm is going to be. So let me head over to there. Hopefully you can see that okay. All right, so we are starting at 0, 0, 0, 0. I mean, I kind of spread them out a little bit so that I could fit everything, but this is 0, 0, 0, 0 combination. That's what we start out as. So that's what we put in the queue first, because it's a n array kind of tree question. It's not a binary tree. It's like an n array tree, so it could be any number of children, not just 2. So that's kind of the structure that I'm going for. So we have 0, 0, 0, 0 as the root, and off of the root, we can have 8 different outcomes, because on the lock, you can switch the lock forward. So that means you can add 1 to one of the dials, and it'll be 1, 0, 0, 0, or you can turn it back. So you can subtract it. So if you subtract 1 from the 0 part, it'll go to 9 here. Hopefully you can see my cursor. So that means if you have 4 dials, there's a total of 8 combinations that you could make on a single dial turn. So these are all illustrated here. So if you have, I illustrated all the 8 that you can go to. So it can be this one, this one. So these are all different nodes that we're now creating off of that root node. So I first dump 0, 0, 0, 0 in there. And then I check if the queue is not empty. So this is a traditional breadth first search algorithm using a queue. And then I check the size. So I see if the size, okay, so I first get the size into a variable, and then I use that size to iterate through all of the elements that are inside that array. So that means I'm iterating through each one of the elements that are in the array. I guess right now, as I'm going through it, we still just have the root one in there. So let's talk about that. So right now we have cur, and it just has the root node in there. And we do a check to see if cur equals target. So if it equals a target, we want to return the count immediately. We don't want to continue processing because we already found our answer. And there's basically, I need to change this, 8 different ways to move forward here. And I do a for loop of size 4, because each one of these numbers, I'm going to iterate 1 at a time, 4 times. But on each number, I'm going to create 2 nodes off of there, because I'm going to add 1 to whatever element I'm at, and then I'm going to subtract 1. So it might be 9, or if this was 1, it would go back to 0. So that's what I'm doing inside this for loop. So I have a current int, which character.get numeric value from the current char. So it starts at 0. So then I would get 0 in this case. If I'm using this. And then I'm using a string builder here. I don't think I actually have to do that, but it was the fastest way I could figure it out. I'm not too good at the substring method in Java. I always forget how to use it. And when you're trying to code quickly, you use whatever kind of comes to mind, or I actually researched this and it looked like the simplest way forward. Anyways, string builder here has a nice method called set char at. So I create a string builder from the cur. So that's the 0, 0, 0 right now. And I set the char at this index. So that's the first index. And I say character.4digit cur int +1. So that's why I'm incrementing. So that's 0 right there to a 1. So this would be 1, 0, 0, 0. After I execute that line. And this 10 here is to use the tens decimal, so you can use like hexadecimal or whatever. But yeah, this method, 4-digit, character.4digit, needs a 10 there if you're using a decimal number, which we are. And then or I guess I shouldn't say decimal. I guess it is defined as decimal. Don't want to confuse anyone. We're not actually using decimals here. These are all integers, but we're using base 10 for the number. So like binary is like base 2. There's other bases you can use, but we're using standard integers like 0 through 9, 1 through 10, whatever that you've learned in school, and we're using 10 there. Okay, so then now that we've set the char there, so now we have basically a string builder that's of this type, or it looks like this, so this string builder. So then we need to convert that to a string, and I call it new combo 1. And then I check to make sure the set does not contain new combo 1, because remember what's in the set, it's all the dead ends here. And then I offer up into the queue that combo 1 as long as it's not in the set, and then I add that number back to the set. Why do I do that? So if you ever have done the Fibonacci problem, it kind of looks like this. There's like a graph or a big array tree that you create from the Fibonacci sequence, and it keeps getting bigger and bigger, and there's a lot of nodes that are the same if you highlight them. I haven't fully highlighted all of the nodes here, so there's no duplicates on this screen right now. Actually, there might be. Actually, this one and this one are already duplicates. So when I add this guy, I'm going to keep processing this one. So I'm only processing it once. But once I get to this one, it's already going to be in the set because I added it into the set. So I'm going to stop processing that one. I don't want this one to go in the queue and then you continue processing it. So it's a lot more efficient to do it that way. The runtime's a lot faster. Okay, so that's adding the +1, and then same thing down here. I add the -1. So I do this quick little logic here to determine if it was a 0. So if cur_int is 0, so let's say we're here, cur_int is 0, then I need to have 9 be the rollback number. If not, then just subtract 1 from cur_int. So then I set the rollback number there. So just a little bit of a gotcha there. And then new combo 2 is what I named that new string. So in this case, if we started with a 0000, it would be 9000, right? Looking at this one, oh, I guess this is this is actually incorrect, so sorry about that. The 9 is supposed to be right here. So yeah, I think you get my point though. All right, so it's supposed to be 90000. Okay, and then this will just keep iterating through. And this curly brace is the end of the for loop. Okay, so if we look up here, this for loop here is when we're going through the entire level here. So we're going breadth first search, which means that we go level by level, visit all the neighbors first. So at the end of each level, okay, we increment the count. So we're seeing how many levels we go down until we hit our target here. Okay, so we increment the count, and then eventually, hopefully, we hit the target and return count. Otherwise, if we go through all possible combinations and we never see a way to do it, then we return -1. All right, so that is it for that problem. I hope that made sense. Let me know if it did not. Give me any feedback you want, and I hope you the best on your journey. Thank you.